Good morning. Thanks for joining our talk this morning. We're going to present the StarlingX containerized platform for the edge. My name is Brent Rousel. I'm a member of the StarlingX TSC.
My name is Bart Wensley. I'm one of the StarlingX cores.
And Greg Wayne's also a StarlingX core.
Okay, so first off, just some of the high-level topics that we're going to cover this morning. We're going to give an architecture overview of StarlingX. We're going to talk a bit about our different deployment models. Then we're going to dive into day one and day two operations. And lastly, we're going to talk about edge device management. So first off, I just want to talk a little bit about what is StarlingX. So StarlingX is a full virtualization stack that's targeted towards edge use cases. Our key focuses in StarlingX are on small footprint, high performance, low latency, deployment and management simplification, and high availability. So I'll just talk a little bit about the stack. So StarlingX will bring in a large number of upstream projects. We're based on CentOS with a plan to go to multi-OS support in future releases. Then we pull in key upstream projects such as Kubernetes, Docker, ceph, QEMU, libvirt, OpenStack. As part of the stack as well, we have a number of StarlingX specific services that we've developed. We have a service called configuration management that's responsible for the configuration of our bare metal host, along with service configuration. We have a host management component, which is responsible for the lifecycle management of the bare metal host itself, does failure detection and recovery. We have a component called service management. It's responsible for managing the life cycle of the bare metal host processes that would run on StarlingX. We have a software management component as well. It's responsible for managing software updates and upgrades of the StarlingX stack. And we have a component called fault management. It provides an API that services can use to publish alarms and events that can be exported to northbound systems. And there's also a component called infrastructure management, which implements some VM high availability features that we have, along with automated software updates and upgrades across the StarlingX cluster. So that's a little bit about what StarlingX is. So what are some of the use cases where you would actually deploy a StarlingX? So vRAN is clearly one. Certainly been a lot of talk at the summit this week about 5G and vRAN. So StarlingX is a great fit for 5G, a vRAN application with its low latency and high performance characteristics. Switching gears, StarlingX would also be a good fit for healthcare. So StarlingX could be used for medical imaging and diagnostics. So picture a server in a hospital. That's something StarlingX would be a good platform for that. And as well, StarlingX could be used in applications such as mobile edge computing, virtual reality, augmented reality, and so on. So we started the StarlingX project last year. It was announced at the Vancouver Summit. Our initial release was in October of last year. So our first release, we provided a hardened OpenStack platform. Since then, we've undergone a pretty significant transformation. So now StarlingX is a container platform based on Kubernetes, and OpenStack now runs inside of containers on top of that container platform. With this new architecture as well, we also have the ability to be able to deploy edge sites that are strictly Kubernetes based, if required. So just some details of our container platform. As I mentioned, so Kubernetes is the orchestration engine for container workloads. As part of our platform, we provide a secure local Docker image registry. We're using Docker as our container runtime. We're leveraging Calico as our networking, cluster networking. For persistent storage, we're leveraging ceph RBD. We've pulled in Helm as our package manager, as well as the Armada component from Airship for the management of more complex applications comprised of multiple Helm charts. We're also leveraging OpenStack Keystone for our registry authentication and for authentication and authorization of the Kubernetes API. So as I mentioned, OpenStack is now deployed as a containerized implementation on top of StarlingX. So we are leveraging the Openstack-Helm project as well as Armada, as I mentioned on the previous chart. For our upcoming release, we're based on Stein. Going forward, we will be tracking the upstream OpenStack releases. So for instance, our next release will be on Train. Just touching on some of the networking backends that we support with our containerized solution. So containerized OVS, bare metal OVS DPDK, as well as SRILV. And I just listed out the different services that we support with our solution. So just want to talk a little bit about our different deployment models. So we have a very scalable architecture. We can start with as small as one server, which combines the control, compute, and storage function. Then there's a 2-node variant of that, which basically provides you a highly available one-node solution. And then we can scale up to a frame-level solution, all the way up to 100 nodes for the edge. As part of this, we have a key focus on minimizing the infrastructure footprint. So for instance, our 1 and 2 core solution, the infrastructure consumes two cores per server. The frame-level solution, we deploy a two-server master implementation. Worker nodes have 1 core worth of overhead. For storage, we've standardized on ceph as our persistent storage backend. This would be both for Kubernetes PVs as well as the OpenStack services such as Cinder block storage and Glance image storage. So again, to further reduce the footprint, so on our 1 and 2 node solutions, this is integrated. Ceph is integrated into those solutions. And then we have storage options where ceph is also integrated into the larger configs, or you can deploy it standalone. And with that, I'm going to turn it over to Bart to talk about platform deployment.
All right, thanks, Brent. So as Brent had mentioned earlier, one of the key focuses for StarlingX is to make the deployment as simple and low touch as possible. So I'll focus a bit on the deployment of the StarlingX platform for the next bit of the presentation. So StarlingX installs on bare metal servers from an installation ISO. And you can build the ISO using the tools and instructions in our repos, or we actually build ISOs daily and make those available, so you can download those from a public repository. You don't have to build them yourself. The Docker images for Kubernetes, they're pulled from public registries, or optionally, let's say you're behind a firewall, we allow you to set up a private registry and pull the images from there. We drive our initial system configuration from Ansible, so this is something new in release 2 that we're just finishing up. Prior to this, we had an on-box configuration utility that you would use, but now you can do this remotely. So with Ansible, you model the configuration for the target, and then Ansible will bring the target up to that configuration. And we did this, one of the main reasons is so you can now automate your deployment with zero-touch provisioning. You can deploy the system from a remote Ansible server. You don't actually have to log into the system itself. And finally, we use kubeadm to deploy the Kubernetes components. The user doesn't interact with kubeadm at all. We do that behind the scenes, but that's the tooling we're using. So here, I'm going to summarize the platform deployment procedure. The first step is to install your first server from our ISO, and typically you'd do that with a Pixie boot server, but you could also do it from USB if you like. Once the installation is complete, you're going to then run an Ansible playbook to configure the server as the initial controller and the initial Kubernetes master node. And like I said, you could either run that playbook locally or you can run it from a remote server. And to simplify things, we've put all the deployment-specific configuration in a single YAML file, so it's very easy to edit any of the configuration that you need to change. Once the initial server is up and running, if you're going to have a multiple server configuration, you'd then install the remaining servers. This is all done in the same way. First, you'd power on your server and Pixie boot it from a controller node, and the controller then discovers it, and the user can then select the personality. So you choose whether you want it to be a controller, a worker node, or a storage node, and then the controller will install the software on that server. Once the server comes up, the controller does inventory discovery to determine what hardware is available on that server. The user can then configure anything specific to that host, like interfaces or how the CPUs are allocated, those kinds of things. And then finally, the user unlocks the server, which reboots it and brings it into service. So once you've installed all your servers, then you would apply any additional system configuration through the StarlingX configuration APIs. So we provide a command line interface, REST APIs, and a GUI as well. So now, if you give me a second here, I'm going to show a quick recorded demo of the deployment of a simplex, so a single node StarlingX system. I'm going to do the deployment with a remote Ansible server. The starting point for the demo is that the target server has already been installed with the ISO and has an IP address assigned to one of the interfaces. So this is what the target server would look like if you'd already done a Pixie boot of that server. So we're going to start off here. So this is on the remote Ansible server. So the first thing I'll do here is just show you our top level of our playbook. So it's pretty simple. It's just going to validate the configuration, and it's going to set up a password on the remote server. It's going to apply the configuration to the remote server, persist that configuration in the databases on the server, and then it's going to start up the services. And as I mentioned before, we have a single YAML file, which I'm showing you here, which contains all the configuration you would need for this initial deployment. So you can specify DNS servers. You can set up your network properties. So for all the networks on the server, you can change the subnets. Optionally, you can specify a Docker registry if you, a Docker proxy if you're behind a proxy, if the target server is behind a proxy. You can also optionally specify a Docker registry if you don't want to use the standard upstream registries. And then also here I've got the admin credentials. Normally those would be in an Ansible vault, but for the demo here I've just got them in the configuration file. So now I'm going to run or the Ansible command to apply the playbook is going to run. We're going to skip through this quickly. Normally this would take about 5 to 7 minutes to run, but obviously we don't want to sit here that long, so we're just going to skip through to the end of that. So Ansible has logged into the remote server and has applied the configuration. So now, just going to pause the demo for a second. So this is the target server here. Normally in a real installation, so for the demo, I'm going to log into the target server and perform a little bit of extra config and then unlock it. Normally in a real installation, you would do this remotely as well through our REST APIs, but the REST APIs don't make for a good demo. So I'm going to just do this locally with the CLI, but just know in the real world, you wouldn't actually have to log into the server to do this. So here we go. First, I'm just going to show you what's running as far as Kubernetes goes. So here we've got our pods that are up already after applying the playbook. You can see we've got the Calico networking pods and Tiller so that we can use Helm. Next, I'm going to use the platform CLI here, and I'm going to list the hosts. So this is a simplex server, so we've got one host here named controller 0, and it's in the locked state, so it needs a bit of extra config. I'm going to do two things. So the first thing, I'm going to list the interfaces. By default, the playbook's going to assign all the networks to the loopback interface, and then the user moves those networks to whatever physical interfaces they want. So at a minimum, you have to move the OANM interface to a physical interface, which is what this command here is doing. And then the other step is you need to choose which disk you're going to use for storage. So I'll list the disks on the server. And in this case, I selected SDB as the storage disk. So this is going to configure that disk as a ceph OSD. That's all that's necessary. Once that's done, we'll unlock the host. That's going to send it for a reboot, and we'll obviously skip through that to speed things up. So the host now is going to go for reboot, and it's done. Next thing here is we're logging into the StarlingX GUI. So this is Horizon-based. It's our platform GUI. So you'll see when we log into here, you'll see Brent had mentioned some of the platform services. So you'll see those here, fault management and identity and our patching services. Then we're going to take a look here at the host inventory, and we'll see that we've got a single host, again, controller 0, and now it's in the unlocked state, so it's been rebooted. It's ready for service. So if we drill down into that host, I'll just quickly show you our inventory panels here. So this is all the inventory information that we've collected from this host, so info about the processor, memory, storage, ports, all that sort of stuff. I'll just go into the processors pane here. And you'll just see that by default, we've allocated certain processors to the platform, to the vSwitch, and to applications. The user's free to change this configuration, but we pick what we think are reasonable defaults. The same thing with memory. We allocate some of the memory to the platform and some of it to applications, and we allocate different sizes of huge pages. And again, that's all completely configurable by the user. Just to finish off here now, I'm going to go into the Kubernetes dashboard. So you'll see here, from Kubernetes perspective, there's only a single service running now, just the main Kubernetes service. We haven't run any application pods. And you'll see there's a single Kubernetes node called controller 0. This is a combination master worker node, since this is a single node deployment. And if we drill down into the controller 0, you'll see here, this is all the details that Kubernetes is tracking about this particular node. If I scroll down a little bit here, you'll see that we only have 10 pods running. Those are the 10 pods I showed you earlier, just the platform and Calico and Tiller pods. You can see the names of the pods here, just scrolling down a little bit. So finally, to end off the demo, I'm just going to go in and create a sample deployment. This is a simple Nginx deployment with 3 replicas. So I'm just going to upload the YAML, and it'll quickly spawn the 3 pods. So that was from start to finish. That's how you would install a simplex StarlingX node with a remote Ansible server. So obviously sped things up for the demo. On real hardware, you'd expect that to take about 25 to 30 minutes, that's including booting the server from the ISO, installing the operating system, all the platform software, everything you just saw there, probably 25 to 30 minutes. And if you're interested in seeing more of that, this afternoon at 1:40, there's a hands-on session for StarlingX where I believe you will actually get to do a deployment. Now, one caveat is that the Ansible functionality I showed you there is was just finished in the last few weeks. So I believe the demo they're going to, or the hands-on session would be using our release 1 configuration mechanism. So it's slightly different, quite similar though to what you've seen here. So that was deployment of the StarlingX platform. So the next thing I'm going to talk about here is deployment of OpenStack on top of the StarlingX platform. So like Brent mentioned, OpenStack is deployed as a containerized application on top of the StarlingX platform. So the OpenStack control plane is running in pods. The virtual machines are just running directly on the host. And we did this, one of the reasons is so that we could leverage Kubernetes abilities in managing and scaling and updating the OpenStack services. And as Brent mentioned, I'll just reinforce this. So we use Helm. So we use the Openstack-Helm project. We use the Helm charts from that project. And we also use Armada to orchestrate the deployment of the Helm charts. And the Armada comes from the OpenStack Airship project. And StarlingX, so what we've done to add value is we provide application APIs on top of these to install and configure the containerized StarlingX OpenStack application. So we have a tarball that contains an Armada manifest along with all the Helm charts you need. And that's a single unit that you can build this, again, with our build tools. They're available to build this application. And then you import it into the system. And I'm going to give a brief demo of that. One of the neat things we do is that if you've used Helm before, you'll know that the Helm charts have a lot of configuration options in them. So we'll automatically generate all the configuration options based on the system configuration. And then we allow the user to update any of the configuration values they want, but they don't need to edit the Helm charts or the configuration YAML files. They just do that through our REST API or our CLI, and then we'll do that for them. So at a summary, the procedure to deploy the OpenStack application on top of StarlingX is very simple. So the first step here is you need to choose which of your hosts you want to run OpenStack. So and the way you do that is you apply Kubernetes labels to the nodes. So you would label the nodes that you want to run the OpenStack control plane, and then you would also label the nodes that you want to run the compute pods. We also support a hybrid deployment where some of the worker nodes could be used as compute hosts, but other worker nodes you could use just to deploy containers directly. So you can have a mix. So the other step that you need to do for the nodes that you want to run the compute services, you have to configure some local storage on there to use as the ephemeral disks for the instances. As Brent mentioned, we also have a ceph cluster as part of the deployment, so you can use Cinder volumes as well for your instances backed by ceph. Once that's done, then you import and apply the StarlingX OpenStack application, and then you're done. At that point, you can configure OpenStack using the regular OpenStack REST APIs or Horizon. So now I will show you another recorded demo. This time it's going to be a deployment of the OpenStack services. The OpenStack application on top of StarlingX. So I'm logging into the StarlingX GUI here. I'm just going to show you, this is a different system. This is a system I've already installed with StarlingX in order to demo the installation of the OpenStack application. So if we go into the host inventory here, we'll see this is what we call a 2+2 system. So there's 2 controller hosts and 2 worker hosts. There's no storage hosts. To keep this footprint small, as Brent mentioned, we're running ceph on the 2 controller hosts here. So that's our 2+2 system up and running. Now I've done a tiny bit of prep work here, so we're going to go on to controller 0, and I'm just going to show you that I've already applied the labels to the hosts that I mentioned before. So controller 0, we're going to look at the labels here. There's a single OpenStack control plane label here. That's going to end up with the OpenStack control plane pods running there. And then I'll just show you one of the compute hosts as well. I've applied a few labels to there, which I probably can't read, but there's an OpenStack compute node label, Open vSwitch label, and SRIOV label. So those are going to control which pods are running on that host as well. Finally, I'm going to go into the storage, and you'll just see that I've configured a Nova local logical volume on this host. Like I said, this would be used for the ephemeral disks for any instances running on this host. So that's all the prep work done there. So now we're going to import and install the application. So we're going to drop down into the StarlingX CLI here. And I've already got the application tarball here. And like I mentioned, the application tarball here, it's got the Armada manifest plus the Helm chart. So the first thing you have to do is you have to upload that into the system. So I'm going to run a system application upload command. And that runs fairly quickly. All it's going to do is it's going to unpack the Helm charts and the manifest. It's going to do a bit of validation to make sure everything is there that we need. And then it's going to store everything in our internal databases. So that's done now. What I'll do now is I mentioned that we allow you to update the overrides. So I'm going to list the overrides we have on the system. So I run a command to list them. And you'll see here for all the charts, all the OpenStack charts here, you'll see that we track overrides for each one of these. So just for demonstration purposes, I'm going to show you the overrides for glance. So these overrides are everything that you configure in the Helm chart. So it's got things like IP addresses and file system paths, passwords, endpoints, everything that you would need to configure to make that Helm chart apply. We split them into two parts. We have a system override, which is what we what we generate automatically from the contents of the system. We have user overrides, which allows the user to update any overrides in the Helm chart. So for an example here, I just updated one of the glance overrides to change the number of worker nodes. I'm going to list the overrides again, and you'll see at the bottom here, you see that now the glance is set to use 2 workers. So it's that simple, a single CLI, and you can change any of the overrides. So now that I'm happy with what the overrides look like, I'm going to apply the application. And when we apply the application, it does a few things. We'll just watch it here. So the first thing it's going to do is it's going to generate the overrides in the format that Helm can consume. So we combine the system and user overrides and generate the files that we need. Then we're going to download the Docker images from the external image registry. And then finally, we're going to use Armada to apply the Helm charts. Now, I'm going to skip through this again. We don't want to sit here and watch it happen. In a real system, it probably would take about 15 to 20 minutes to apply all the Helm charts. So we'll just skip through here to the end where the application is finished installing. Now, the first thing I'll do after the application install is done is I'm going to list the pods running in the OpenStack namespace. So you'll see here that applying that application has now created all the pods for all the different OpenStack services. They're all up and running. So now I'm going to switch over. I'm going to log into Horizon now. This is just the standard OpenStack GUI. And we'll just take a look at a couple things here. So the first thing we're going to look at, remember this was a 2+2 system and I labeled 2 hosts as compute hosts. So if we go into the hypervisors here, we should expect to see 2 hypervisors. So once that comes up, you see that we've got 2 hypervisors, a compute 0 and a compute 1. And then the other thing I'll do is I'll just go into the system properties here and I'll show you the OpenStack services and all the endpoints. So you can see here the list of all the OpenStack services that we have installed along with all their endpoints. This was all configured through the Helm charts. And then finally, I'm just going to spawn an instance to end the demo. I did 2 things, but I cut out of the demo. I uploaded a Ceros image, and I also created a couple neutron networks. So we're going to spawn a Ceros instance here. We're going to boot from the image that I uploaded earlier, just a simple Ceros image. We're going to choose a default flavor. And then I'm going to select a couple of the neutron networks that I configured and click on Launch Instance. And in a few seconds, you'll see the instance starting to build, and it'll go into the running state. So that's it. That's all you need to do to install OpenStack on top of the StarlingX platform. Obviously, sped things up for the demo here. But on a real system, you're probably looking at about 20 minutes start to finish to deploy the OpenStack application on an already configured StarlingX system. All right. Now I will get back to the slides and hand it over to Greg.
Yeah. Excellent, thanks. Okay, so StarlingX actually provides full lifecycle management of its deployment. So besides the day one install and deployment that we just saw, we actually provide a number of day two operations. So some examples of that are any subsequent configuration that you need to do after installs. So if you're adding a new node, or if you're modifying some of the configuration of the OpenStack or even Kubernetes services. We also do maintenance across both nodes and hardware, as well as software services. For example, we have admin commands where, like, for example, you can lock a node to take it out of service if you're going to swap a hardware component, a disk or something. And those are intelligent admin commands that proactively deal with the hosted workloads that are on the node. We do fault monitoring, again, for both hardware and software, raise alarms on any faults that are detected, and we have higher order recovery mechanisms to recover from faults that we detect, both the platform level and again, at the hosted workload level. We collect stats on hardware and software entities, and then we can also push logs from all of the nodes in the system to centralized Elastic log servers so they can be analyzed off switch and in a central location. We also provide software updates, so fixes to any layer of software from the kernel, StarlingX, Kubernetes to OpenStack services, as well as upgrades, which are transitions between major versions of software. And we provide orchestration tools for managing that, because as soon as your cloud gets above half a dozen nodes or something, this is a lot of work to do across all those. So we provide orchestration tools to automate a lot of the update and upgrade steps. And then finally, for disaster recovery scenarios, we do have backup and restore capabilities. Okay, so the last thing we're going to talk about is just some future work that we've been experimenting with. So it's edge device management. And actually, there's a number of different use cases and scenarios for edge device management. We've done a proof of concept demo. I'll show you a recorded demo of that in a sec. So the use case that we did the proof of concept demo on is, so the context is that we have a StarlingX edge cloud deployment. You can see it there. And it's a StarlingX R2 deployment where I've got a Kubernetes cluster as well as potentially an OpenStack containerized cluster. And then I also have small IoT edge devices. And in this use case or scenario that we were looking at here, those devices kind of come to the party with their OS already installed, Kubernetes already installed. And the idea is the proof of concept demo is about supporting the ability to kind of securely join them into our StarlingX Kubernetes cluster. And the value you get out of that is the fact that now from a single point, the StarlingX controller or Kubernetes master, I can now manage containerized applications across both my cloud servers in my StarlingX cluster, as well as across these edge devices. And then a secondary value is the fact that these containerized workloads running on these edge devices now, they're part of the StarlingX Kubernetes cluster. So any services that are running on our Kubernetes cluster are available basically to these containerized workloads on the edge devices. So they can leverage our ceph pool and create basically Kubernetes persistent volume claims that are backed by our ceph cluster for persistent data storage. They can leverage our local Docker registry or load balancers and that sort of thing. So this is the context of the demo that I'm going to show you. I've got a little 2-node StarlingX cluster, one controller or master and one compute or worker node. I've got a Raspberry Pi. And so even these small devices like Raspberry Pis now can run Kubernetes. So I've got a Raspberry Pi. It's got Raspi and StretchOS on it. I pre-installed Docker and Kubernetes, just all open software. We stuck a temperature sensor on the Raspberry Pi and an LCD display so it could do something neat. So I'm going to join the Raspberry Pi into the StarlingX cluster, and then I'm going to deploy a simple multi-container application, and it's a microservices architected application. I've got a bunch of containers that do small activities. So I'm going to launch 2 containers on the Raspberry Pi, one that's going to monitor the temperature sensor and provide a messaging interface to the other containers. The other container on the Raspberry Pi is going to drive the LCD. So it's going to use that messaging interface to get the temperature and then display it on the LCD. And then I'm also going to deploy a web server on the StarlingX cloud servers, or the compute there, that will also use a messaging interface to display the temperature on the web server, though. Okay, let me just get my glasses on so I can see. Okay, so this goes kind of fast, so I'll stop it. So I'm logging into StarlingX now, and I'm going to the host inventory, and you can see that I've got the one controller host and the one compute host. That's my StarlingX cluster. And I'm going to pop up Kubernetes dashboard to basically just show you that this is the StarlingX kind of R2 solution where our nodes are running Kubernetes. And so I've got a 2-node Kubernetes cluster here. Then I'm going to go back to host inventory, and this is my Raspberry Pi with my LCD and my temperature sensor. And down at the bottom of the host inventory page, I'm going to basically inventory this Raspberry Pi. So what I'm doing here is I'm basically putting the IP address of the Raspberry Pi and some credentials there so that I can remotely run the kubeadm join command to allow it to join the cluster. So do that, and then you'll see it show up down below as online, basically, which means I can ping it. So I'm going to run the join command now. So basically, the join command, basically what it's doing is it's generating a token so that when I run when the remote command runs on the Raspberry Pi, that token can be used to authenticate the request to join the cluster. So I run that. And you can see that the node transitions to ready, and I pop up the Kubernetes cluster now, and you can see that now the Raspberry Pi has joined the StarlingX Kubernetes cluster. And so now what I'm going to do is I'm actually going to deploy that application that I was talking about. So I'm going to use Kubernetes dashboard to deploy it. I've got a YAML file that contains the definitions of those 3 containers that I talked about. So I'm going to launch those, and you can see they launch, and kind of circling the 3 containers there. I don't know if you can read the LCD display. It is actually showing the temperature, but you can see the pods at the bottom that I circled there. 2 of them got deployed on the Raspberry Pi. The other one actually got deployed on the controller. But yeah, so this is a kind of quick proof of concept of, like I say, one use case of edge devices and deploying a containerized app on those edge devices from StarlingX.
Okay, so just quickly wrap up here. So just to let you guys know, we're holding our PTG session Thursday noon to Friday end of day. So we would encourage anyone that's interested in StarlingX to join our session. Just listed some of the summit sessions that we've given already this week, and just point out a couple that are coming up later today. So we have our project onboarding later this morning, and we have an all-afternoon hands-on workshop. And with that, take questions.
Howdy. So most of the OpenStack infrastructure services and ceph, the control plane relies on having 3 copies of each service for different voting algorithms that do like a majority quorum, like your ceph monitors and your Galera database for OpenStack. But I see that your example only has 2 control plane hosts, 2 infrastructure hosts. Can you explain why you chose 2 instead of 3?
We chose two to minimize the footprint for the edge.
Okay. So you're still running 3 copies of those services, just 2 on one host and 1 on the second?
So for ceph, we do run 3 monitors. So we would run 2 on the controllers, and then we would run 1 monitor on one of the worker hosts.
Okay, thank you.
Thank you.
If I have 100 remote sites and I deploy Kubernetes through StarlingX, will I have single Kubernetes cluster, or do I have Kubernetes control plane in each site?
Yeah, so I think you're referring to our distributed cloud architecture, which we didn't cover in this session. But in that model, each edge site would have its own Kubernetes cluster.
So to deploy pod in specific 3 sites, I will have to go to each one of them and deploy them.
So that each site can be deployed remotely from our central cloud.
Okay, thank you.
I think we're out of time.
Any other questions? Thank you very much.